Hi, Algebra 1 students. Mr. Masonoff, Mr. Lasanti, and myself all miss being able to interact with you guys in class and do regular lessons, but we are enjoying being able to still teach you and work with you virtually. One thing that the three of us noticed today is that a lot of students, as they've been working hard on the 4.3 and 4.4 module quizzes, is that they are missing the average rate of change question. So we thought we'd put together a little mini lesson and an example on how to calculate the average rate of change of exponential functions. So for this example, we are given the exponential function, f of x is equal to times 4 raised to the power of x. Section A is from x equals 0 to x equals 1. And section B is from x equals 3 to x equals 4. And we want to find the average rate of change for each section. Before we get started, whether we have a linear, whether we have a quadratic, whether we have an exponential function, the formula for finding rate of change is the same. And that formula is y2 minus y1 all divided by x2 minus x1. This is our formula for finding rate of change, ROC, rate of change, okay? All right, now, as we look at that formula, we see that we need both x values and y values. In analyzing the information that was given to us, they provided us with the function, so the equation, and for section A, the x values of 0 and 1. Since we have the equation and our x values, we can use substitution to find the adjoining y values. For the very first one, where x is equal to 0, we're going to substitute 0 in for x, and that will allow us to find our y, or in this case, since it's a function, our f of x. Because remember, f of x is the fancy way of saying y. If I substitute 0 in, instead of f of x, it is f of 0, and that is equal to 2 times 4. And then since I'm substituting, instead of it being raised to the power of x, it's raised to the power of 0. When I go to simplify this, I need to follow order of operations, so PEMDAS. The first thing, P parentheses, really means grouping symbols. When I look at this, there aren't any grouping symbols. So I can move on to the next step, which is exponents, which there are exponents. So we need to start with 4 to the power of 0. What is anything to the power of 0? It's 1. So we have 2 times 1. Sorry for my handwriting. I am not able to get this to work on the iPad with the Apple Pencil yet. So just some little humor in the way I write things. Now we can multiply. 2 times 1 is 2. So f to the power of 0 is equal to 2. So we have our x value 0 and our y value 2. We can do the same thing now to finish off section A for x is equal to 1. So once again, we'll substitute. So f of 1 is equal to 2 times 4 raised to the power of 1. So we start with our exponents again. 4 to the power of 1 is 4. So we're left with 2 times 4. 2 times 4 is 8. So f of 1 is equal to 8. Now that we have all of that information, we can find our rate of change. If we look over at our formula, we need to identify our y1s, our x1s, our y2s, and our x2s. So we're going to just do that by the first point, or the first equation here is going to be my first one. So this is my x1, that's my first x value, and then this is the matching y1. Over here, my second one, so this is my x2, and this is the adjoining y2. Now that it's labeled, we can substitute that into our formula. So y2 minus y1. So for section A, my y2 is 8 minus my y1, which is 2. All of that is divided by x2 minus x1. So x2 is 1 minus our x1, which is 0. Once again, when we simplify this, we need to follow order of operations. So PEMDAS, P grouping symbols, I do have that in this case because one of my grouping symbols is a fraction bar. We need to make sure the numerator and the denominator are both simplified before doing that division. So 8 minus 2 is 6. 1 minus 0 is 1. Now that my grouping symbol is simplified, I can follow through with the division. And my rate of change for section A is 6. So ta-da, that's it. Now we need to do the same thing because it wants it for each section and find our rate of change for section B, which is now from x equals 3 to x equals 4. But we are using the same equation because it is the same function. Now we're going to substitute 3 in for x. So f of 3 is equal to 2 times 4 raised to the power of 3. When we do our exponent here, we want to be very careful. We need to remember that an exponent means it's 4, your base, being multiplied 3 times. It is not 4 times 3. So please make sure you remember that it is an exponent. So we have 4 times 4 times 4, which is 64. So 4 to the 3rd power is 64. So we're left with 2 times 64, which is 128. So f of 3 is equal to 128. Pretty easy. Now let's do our last one. X is equal to 4. So f of 4 is equal to 2 times 4 to the 4th power. So once again, that means your base 4 is being multiplied by itself the exponent number of times. So in this case, 4 times. So 4 raised to the power of 4 is 256. So we have 2 times 256, which is 512. So f of 4 is equal to 512. Now that we have both our x and our y values, we can use our rate of change formula to find the answer that is desired. All right, so once again, let's label our numbers so that way we make sure we substitute them correctly because we can't mix our x's and y's from one equation to the other or from one ordered pair to the other. So f of 3, so the 3 is our x1 because it's our first one. And then this is the adjoining, the matching y. So that's our y1. And then 4 is our x2. And 512 is our y2. So let's substitute these into our handy dandy formula. y2 is 512 minus our y1, which is 128, all divided by x2 minus x1. So 4 minus 3. Once again, we need to simplify our numerator and denominator first. So 512 minus 128 is 3, struggling with the 3, 84, all divided by 1, which is 384. Ooh. That right there is just proof about what we talked about before spring break, that exponentials grow very, very quickly because from section 0 to 1, it only had a rate of change of 6. but then we just went up a little bit, and from 3 to 4, it jumped all the way up to 384. The nice thing with this, guys, is sometimes your information will be presented to you as an ordered pair or in a table. And if you already have both your X and your Y values, you can skip the first half. And all you have to do is substitute into the formula. So sometimes you may have to do the extra step and find your Y values. Other times we have given you all the information you need, and all you need to do is substitute in the formula. I hope this has been helpful to you. If you still have some questions or you would like a one-on-one or a small group session, please reach out to either myself, Mr. Masonoff, or Mr. Lazanti. We are here for you, and we are more than happy to give you the supports that you're needed. Thank you very much, and I hope you guys wish you the best of luck on your next quiz.